right, we're going to talk about direct variation today. And so with direct variation, we need to understand what it is. So it's y equals kx, where k does not equal 0 and is called the constant of variation. So one of the things that we want to recognize is that y over x is going to equal our k. So identifying direct variation both through a table and through an equation. So the first thing is we're going to look at through a table. So one of the things up here we said was k equals y over x. It always has to be the same value. So what we're going to do is we're going to set up proportions here. We're going to look at 2 over 1, 6 over 3, and then 8 over 4. If these are all equal, then we have direct variation. And I do need to look at all of them. I can't just look at the first two and say, oh yeah, it's direct variation because the first two. I have to look at all the points. So here I have 4 over 1, 8 over 2. Well, those are equal, right? We can see that. And then I have 11 over 3. Well, those are not equal. So this is not a direct variation. Okay? Now, in an equation, one of the things we're going to do is we're just going to solve for y here. Okay? And I'll kind of tell you a shortcut a little bit, but sometimes that shortcut, you need to make sure you understand what you're looking at. So when we're solving for y, we're going to get it in that y equals, so I'm going to go here, divide by 3, y equals 7/3 x. Notice I don't have a b here, so this is very similar to y equals mx plus b, but b is equal to 0. So this one is a direct variation. So we don't have that, we're not adding any constant. So the next one, I'm going to divide by 7. And y equals 2x plus 1. That plus 1 causes it to fail. So it is not a direct variation. So anytime you're adding or subtracting a constant, if that constant remains there, it is not a direct variation. We can't add anything on to that kx, okay? So now we're going to look at it when we kind of write it out. How is it going to look like? And it says, suppose y varies directly with x, and y equals 9 when x equals negative 15. What is y when x is 21? So our question is, what is y? Now, the problem is we don't have an equation, so we have to work back to that equation. So if you remember, it's k equals y over x. So what we're going to do is we're going to take our first x and y coordinate here, negative 15 and 9, and plug it in. So 9 over negative 15, that reduces to negative 3/5, and there's my k. So now my equation becomes y equals negative 3/5 times x. And it asks me for y when x is 21. So I'm going to plug in 21. Negative 3/5 times 21 gives me negative 63 over 5. I'm going to leave it like that. I could put it in decimal form, but I'm going to leave it in fractional form. Okay. Now, example 4 is a story problem based on direct variation. It says sales commission varies directly with sales. For $1,000 in sales, the commission is $85. What is the commission for $2,300 or $2,300? Now, you could solve this through proportions. That is true. But we're working on direct variation, so I'm going to set it up as a direct variation. So k equals y over x. So that's going to give me 85 over 1,000, which is 0.085. Now I have my equation here, 0.085 x. I'm going to plug in 2,300, 0.085 times 2,300 is going to give me, I think it's 195, 195.5, so $195.50. Last thing we're going to talk about is graphing a direct variation. Well, the nice thing about graphing a direct variation is this is just a line. It's a line that passes through the origin. Every direct variation will pass through the origin. So the nice thing is I already have a point on my graph. So there's my point right at the origin. Now, from that point, I'm going to use my slope. So here I'm going to go up 3, 1, 2, 3, to the right 4. There's my point, and there's my ground. So remember, direct variation is a line that goes through the origin. The constant of variation is going to be y over x. So that's direct variation.